Thanks, Pavel, for the introduction. Hello, I would like to welcome everyone warmly. I would also like to thank the organizers for having me and for organizing this excellent conference. I would like to be speaking about Alpakka, which is something that you can use for reactive enterprise integration. And as I'll be going, I'll be trying to define what actually reactive enterprise integration could also mean. You can find me on Twitter by this weird handle. Okay, as Pavel already mentioned, I worked at Actix, and at Actix we are doing factory shop floor automation. That's a factory shop floor. This photo is pretty old, but actually factories haven't changed that much until recently. So this is like quite a recent photo of a factory. You might see that it looks very much similar to the one from the 50s. So what we want to do, we want to change this by introducing some sort of software that's going to help the factories operate. But my talk is not related to what I currently do. It's more related to my past. I wasn't exactly an alpaca herder in the past. There were many people in computer science are actually choosing to change their careers into alpaca farming. Alpacas are very nice animals, as you can see here. They love to come in large throngs and do weird stuff. But this is not why we want to speak about alpacas. We want to speak about this particular alpaca, which is a library that's part of the Akka project. And this is a library that wants to do the enterprise integration, so wants to help you integrate your software with some other software that is on the outside that you might meet working. So all the kinds of databases, all kinds of queuing system, all kinds of external resources, and it wants to do it in a reactive way for a particular definition of reactive, which is Akka streams. So this is connected to what I was doing in my past, because I was doing a lot of integrations as I was working in a space where I was doing software for banks. And banks basically have lots of various different systems, and you need to integrate a lot. So Alpakka is also not Camel, obviously. And Camel is something that I would be using a lot in my past to actually integrate with other enterprise systems. Camel is a library that basically allows you to connect things following the book Enterprise Integration Patterns. So if you don't know this book, you probably should read it, or at least skim through it. It's like a repository of integration patterns, and they have been implemented in the Camel library. So this is a sort of exemplary integration pattern. We have an order message coming here through a channel. Then we do something with the message. We disassemble the message into parts, then process those parts, then put all those parts into a channel. Then we aggregate that stuff. Then we route based on the content, and then we push into various channels. So this is what people do in banks. If you think, like, a lot of that is actually copying and pasting the data from here to here. So these are some kind of meaningful systems, and this is just the plumbing you need to do to actually push the data. But that's a lot of work, and actually the work that needs to be done in the real life. That's a special case of a connector. It's a dynamic router. So if you see it, it has an input channel. And then based on the dynamic rule base, it sends message to one of the output channels. So pretty common task in software integration. So you might say this actually comes very cheaply in actor-based systems and in Akka in particular. And you'll be very right to say so. There is a very nice book by von Vernon, which describes all those enterprise integration patterns. Actually, how do you do them in Akka with actors? But obviously, actors are not the easiest thing to use in your application. So actors are missing a lot of things. One of them is the streaming abstraction, the other is the back pressure abstraction. So working with actors might be a bit tiring. You might find it difficult. So you might wish to change this paradigm to an Akka streams paradigm, but beware. For instance, the pattern I've just shown you, it's not very simple pattern in Akka. It's actually quite recently added partition hub, which has the ability to dynamically route things, because it's like the fan out patterns up until recently used in Akka were more statically defined. So you would have to define all your outputs up front. So this is something quite advanced in Akka, and also maybe not available in other streaming systems. So like fully dynamic routing idea that you can go to a hub and add a subscription on ongoing basis. Okay, so getting back to Camel, why Camel is actually so cool. Why I think Camel is so cool, and everyone doing integration thinks Camel is cool. Because of that, this is actually a product you can buy. This is a list of all things that Camel integrates with as your bathroom curtain. So you can shower curtains, like the elements, table of elements, and you can actually buy it for your shower. And I just came across this in the internet. This is like the sweetest part of Camel. So let's say you would like to use Camel with Akka. That's possible. One of the options is the old Akka Camel connector, where you basically plug a Camel as an actor, and then you can define kind of receive thing, and then there is this Camel message. You don't exactly know what it is. You need to look it up in the Camel documentation and then figure out how to work with that. On many projects, people have been actually plugging that stuff, because you can actually plug an actor at the end of your stream and terminate your stream with an actor, or start your stream with an actor. That has some issues with back pressure, obviously, but can be done. But it's not very good, because if you're missing some things, then your project will be obviously wrong. So someone came up with a sort of repository for Akka Camel, Akka Streams Camel integration. That's Martin Krasser, and it's called Streams Camel Akka. And actually, that's one of the modules that is available in the Alpakka library. But I won't be talking about that. I mean, we spent already around 10 minutes, but it's not what I want to speak about, because of the problem is impedance mismatch. So on one side, you have Camel API, which is much more aligned to the abstractions you're integrating with. On the other hand, you have the Akka Streams abstractions, which is much more streamlined and very much cares about back pressure and about the streaming abstraction. So the Camel connectors are not the best connectors for your Akka Streams stuff. So if you want to connect to Akka Streams, this is what the Alpakka project introduced. These are native connectors that are actually enabling you to connect natively with the Akka Streams. So you see there's a lot of connectors. It does AWS S3, it does Cassandra, it does JMS, does MongoDB, a lot of things, does file integration. It also has a Kafka connector, which is very well known. It's actually an external integration, but it's more of an internal integration, because the reactive Kafka library, the software wheel, has been taken by Lightband into the Akka project as the reference Alpakka implementation. So this is something like what the project has started with. And I think it's the most comprehensive and most rich in terms of abstractions integration that shows you actually that this can be done. Okay, so let's start with an example. How can you integrate your Akka streams with using Alpakka with external world? I'll be using a JMS connector. So this pretty well matches the abstraction, the streaming abstraction. So I have a stream. and I'm pushing things, I would like to push them a bit further into the JMS. Makes sense. Obviously, there's some other system on the other side that will be receiving that information. You probably already spotted here, the Alpakka doesn't come bundled. It has individual repositories. So you can have different versions for different Alpakka components. Probably it makes sense. So it's like rather a federation of libraries than a single library. It's also an important point. All right, so let's walk through an example. That's a code, actually, just one of the samples that you can access at the web page. And it starts with JMS source. So this is a Akka stream source that basically says JMS consumer text source, and you need to configure it with JMS consumer settings. So you say buffer size and query. This is kind of important because that's the buffer that's going to sit between you and the JMS query. Buffers are quite important in the Alpakka world because of back pressure, but we'll get to that in a minute. So then, after you've just done this plumbing stuff, which is pretty easy, you find it in the manual, then you go through here. So you take your JMS source and then map that what's coming from JMS to byte string, because that's the native Akka streams format. Then you, for instance, can zip it. This is a nice pattern from using a state, so like getting the numbers. You do from iterator, and here you just generate the numbers. So this is a generator of the numbers. You zip it with the numbers, so you get a pairs, number, and the message. And then you map async unordered, because you want to be fast, and put them in the files. This is pretty frequently, I mean, I was using it quite frequently to integrate with legacy applications. So I would have a JMS query on one side and legacy application that would only be willing to read messages in text format. What do? Plug something like that in between. And this is really easy. I mean, that's not even half page of code. That's like a few lines of code, and I'm basically done. Okay. By the way, stream abstractions are not the easiest abstractions. So let's say that's an actual issue from this JMS connector saying JMS doesn't handle failures. If anyone has been to my Akka Streams workshops, Akka Streams is very keen on swallowing your exceptions. Actually, it doesn't swallow them, it reifies them as stream messages. So you might think about the nice functional word. When you have an exception, instead of an exception, you're getting an either that hasn't left. And now you need to handle the left thingy. So what are you going to do? You either log it, or you maybe retry it, or maybe you just do an actor lifecycle, but then that brings us back to actors. So you need to be kind of very careful with that sort of abstraction. When you're doing integration, it might be a tad hard to do it in a streaming way. You might need to be on the watch out for that sort of thing. Hopefully, the team is very helpful, like people are discussing those issues. And if you go through the issues, so this issue is actually left pending, not because it cannot be resolved, but it's just something that people come across very frequently. So it has been left as just an example for how to do the integration. Okay, back pressure. So we come to the most important thing in streams, the back pressure thingy. And I think that's the most important element when you want to either use the Alpakka integrations or whether you want to create your own Alpakka integrations. Okay, first, MongoDB. That's my favorite. I obviously like MongoDB very much. And actually, MongoDB connector is based on the Mongo Scala driver, which uses a very nice abstraction, namely an observable. But let's see first, how do you apply the Mongo connector to Alpakka? So basically, this is the code that exactly mirrors the Mongo code everyone would write, just to connect to the Mongo thingy. So you say Mongo client, get me this database. Then you say, okay, connect to this Mongo cluster, then get me this database, and then get me this collection. So this is like a database table. And then I can say Mongo source, and here I put a query in the Mongo DSL of stuff that I actually want to get. And because Mongo Scala driver actually works on the reactive basis, so it has these abstractions built in, then back pressure is, I'm getting the back pressure for free, basically. So this is the code from the connector itself. It just does a conversion, observable to publisher. This is an RxJava publisher, and then it just plugs it into the Akka streams via the reactive streams publisher. And obviously, that's the back pressure all the way down. So this is the best integration, the best case we would like to get. Whenever you're trying to quench your source, then the source will emit slower or will stop from emitting the events. So the easiest case. If the thing you're integrating with knows the idea of back pressure, you're done. And that's the best case. Okay, another case, Cassandra connector. That has been already discussed yesterday in the benchmark discussions, that people were trying to second guess why Akka streams, why Akka streams connected with via Alpakka to Cassandra was slower than expected. So some of the ideas were around the loss of back pressure on the connection with the Cassandra thingy. So like maybe Cassandra pushing tons of things into memory, then memory growing, and then the stuff, maybe GC, maybe something else, some slowdown. Let's look first, how would we use the Cassandra connector? So exactly as in the Mongo example, we need to get in touch with the cluster. So that would be like very much native Cassandra use case code. Then we just have a statement in the almost SQL-like Cassandra query language, and we need to set the fetch size to something, and then we just run it on the as a source in the Akka stream. So what happens under the hood? Let's take a look at the source code. This is just one of the part of the source code. It starts off with maybe rs. So I wanted to save you the very async stuff that's behind the maybe rs. Basically, if you want to get something from Cassandra, you use a maybe rs as intermediate. So you send a query to Cassandra and offer a callback, and this callback is going to supply data to this maybe rs thing. And then you can maybe get the data as the name suggests. So let's say maybe rs is something. So we actually got an rs, so some data on the inside. Then what we can do, we can, if rs has some data and we don't need to fetch it, then just push it to the output of this fancy stage. So I have a data, let's push it. That's something if I have the data buffered. If there's no more data to come from Cassandra, then I'm done. Let's complete the stage and let's finish the operation. Now what about situation where I don't have the data, but Cassandra has some more data? You see? I'm just fetching the next page. So I'm saying fetch more results, and then I'm waiting for the callback to complete. So this is a very interesting case because Cassandra actually has a support for paging your queries. So when you do a query against Cassandra, you'll get pages. So what happens in Alpakka, you run a query on Cassandra and says, please get me all the data, but instead of getting all the data, you're getting just a chunk of data. So it's not as good as the Mongo connection, obviously, but it's not utterly, rubbish either, because you're getting a limited amount of data. And then you push the data in the stream as soon as the stream, eats all the data, then you can fetch some more data. There is some issue here, though. I just spotted it that second, because I was thinking about some other thing I was doing in the past. Namely, let's say you want the next page. You want it now, so your stream is running, you want the data now, but it actually doesn't do prefetch. You ask for the data, and there will be wait between all those chunks. On the chunk boundary, you will need to wait for Cassandra to actually reply. So this doesn't do prefetch, but you could actually modify this stage, doing some clever tricks, so that it does some prefetch. So maybe it just takes a buffer and next buffer, so like 2 buffers, and when the first buffer is depleted, then it just asks underneath for to fetch more data. That transformation is fully possible. Okay, so Cassandra is very cool. Now we are coming to file connectors. So let's say you would like to connect file, maybe tailing a file into a stream. So this is a hard one. You have a large file, you just want to read all the contents of the file and then tail it into the stream. So the native Alpakka connector is also very clever in that regard. Let's see how it works. So how do you use it? Well, it's the standard stuff. It's very easy to use. Basically, you just write the code. You would be writing without that Alpakka thingy, because the abstractions are usually done 1-to-1. So you do the file systems get default, then you create a source, you need to configure it. Please note maximum line size. That's interesting. Maximum line size. That's actually maximum buffer size, as you'll see. So you need to define that. So no luck reading files that have lines of unknown length. That's the price you probably need to pay. And basically, if you want to read files that don't use lines as an abstraction, underlying abstraction, then you won't be served well by this connector. So this is like caveat emptor. And polling interval. So obviously, how often I'm going to check the file, and then I can just run this cool thing. What's happening underneath? That's a pseudocode of the code from the library itself, namely on pull. So when the downstream of this stage says, get me some more data, I'm going to schedule a callback trying to read a max line size chunk from the input file. So actually, I'm going to read the next line. So this is why this problem with back pressure forces the code to use this abstraction underneath. So I think Jamie has had an excellent keynote about reactive being a product. So basically, it leaks to our basic assumptions, to our functional requirements of what we can achieve. So like this reactiveness, if you want the back pressure, you want to fit it in here somehow. So you basically schedule a callback, try to get the max line size, and then this callback will push out the contents of the buffer read in a callback. So pretty much similar to the Cassandra stuff. So we have a buffer of maximal size, max line size, and this is what we are bounded on. All right, so far so good. Streams Kafka, that's the hard case. So what do we know about Kafka? So for instance, does Kafka do back pressure? Kind of, recently, maybe. But Kafka is not very well known for back pressure, is it? No, it doesn't do back pressure, yeah. So Kafka actually wants to push everything towards you as soon as it is available. So if you say, get me the data, it will get you all the data from the point from the marker of the last read to like now. It may be a lot of data. So how does the reactive Kafka connector deal with that? This is the very cool pump function. It might take you a while to actually find it in the source code, but it's there, neatly hidden, tucked away. So pump is going to check whether the out is available. That's a tricky thingy. With the streams, I've already been saying that brave souls are writing their custom stages, Akka stream stages, so that know that the port cannot be, let's say, pushed twice. So you just have the stage and you do just magic push, but it's actually done in such a way that the interactions, the trace of the execution will never contain two pushes. But actually, the less brave souls are using the is available function, saying, okay, can I actually do that? Can I actually push the port? Just making sure. You need to sort out the thing if you want to use it. Then you should actually be retrying this operation, because if you don't push because it was not available, you need to make sure that you will try to push if the port is available, because otherwise you won't be getting data. I was actually trying to write an Alpakka connector and custom file connector, because the one that doing file abstraction wasn't good for me. It was for binary streams, and this was the case that I was missing. I was actually trying not to do the push twice, but this is what I have tripped on. So let's say if buffer, so there is a buffer, as you've seen in the past examples, there needs to be buffer. If buffer has some elements, then I just push the next element into the stream. So I'm working with an internal buffer, as in previous examples, and I'm just pushing the elements from this buffer in the stream. But what will happen if I don't have this buffer? I mean, no data. I need to ask Kafka for some more data, and I will just tell the Kafka consumer actor, because there is such thing in reactive Kafka, I will say, I request messages. Please get me some messages. And what will happen then? The actor will go to Kafka and will say, Kafka, give me some messages. And then, zhoo! Okay? It just depends on how many messages Kafka has for you from your recent query. So basically, this is Kafka polling, but it's not in the regular intervals. It's somewhat back pressured. So if you're not consuming fast enough, you won't be polling Kafka. But, you know, kind of when you do eventually poll your Kafka firehose, then you might be in for a big trouble. Until Kafka supports properly back pressure, that's unsolved problem. So that's the hardest case. And the problem is not Akka streams, not the connector itself, but just the Kafka. You cannot do it differently. Though the architecture of the connector, as we already discussed in the Cassandra connector discussion, is done in a way that if Kafka would support back pressure, then it would be pluggable. So we could do such a thing. It's like maybe select offset reading. Okay, so now we are getting to the practical side of Alpakka. Well, actually, I'm not the Alpakka contributor. That's kind of a disclosure. I haven't contributed anything so far to the Alpakka, but Alpakka is basically a library that lives on contributors. So there is not much code there done by the Akka team. There is mostly code contributed by someone else. So what Akka team is doing, they are helping to create an environment in which people can contribute the solutions to their own problems that may be reusable for someone else, but actually not much code. So every contribution is welcome. And basically, there is an interesting contributor advice. So we covered part of that. So I've just shown you some interesting Alpakka stages and the issues that are down there. But if you'd like to actually contribute something to Alpakka, then obviously you need to remember about the stuff that you need to be nice for the Akka streams consumers. So do stuff in a way that's idiomatic for Akka streams. So for instance, the guy who was trying to contribute and who finally contributed the Mongo Mongo stage actually didn't at first fit very well with the abstraction, because the first idea was to publish the information in a materialized value. Materialized value is okay, it works, but it would work better if he just made it a stream. It's like the major sort of way how data is propagated in Akka streams, and this has been later refactored into exactly that sort of way. So you need to be wary of that. The other thing is that you need to create relevant things like abstractions. So maybe sources, maybe sinks, maybe flows, if those are important to you. So it's like Kafka consumer will be a source, but Kafka producer, so like if you want to push into Kafka, that's going to be a sink. Luckily, Kafka is so fast that you don't need to think about back pressure. In that case, you just push anything to Kafka, and hopefully Kafka will sort it out. Okay, the other thing is flows. So that's the thing. So when you're designing flows, make them meaningful. So for instance, in the case of a Kafka offset commit, so you get the information, and out of the stream comes the information of like requests to commit certain offsets, for instance. That's a reasonable abstraction. And you need to do a graph stage checklist. So like, do not do mutable states outside the graph stage logic. Open your connections in pre-start, release resources in post-stop. So we know that from, let's say, C++. That's a basic constructor-destructor thingy. And you're using external resources, so you need to be wary of that. So your stage needs to manage those resources. If you have some more complex resources to manage, then you just need to think about that more carefully. No blocking at any time, which should probably come with a star, because we've seen already today some little blocking, maybe in one of the slides. So avoid blocking whenever possible and replace it with asynchronous programming. So that's basically the stuff. And integration testing. I think that's the hardest part of actually contributing anything to the Alpakka project, because Alpakka is about integration, and integration testing is always hard. So one of the options is to supply your thing as a part of the Docker container that's going to be run on the build system, and hopefully it will work. This has certain limitations. So for instance, S3 cannot be probably supplied as inside a Docker container, so the build needs to contain the information needed to connect to S3. Let's say you would like to contribute an Oracle Alpakka connector. That would be difficult to test without ability of like shipping an Oracle database and so on. So probably the connectors you will meet in the Alpakka project are mostly around the open source stuff that you can actually, or the stuff that you can actually package for free, at least in the test environment. Best, basically, ask for help out there. Okay, that's everything from me, and I think we have a few minutes for questions. If you have any, I'll be happy to answer them. Thank you. Any questions? How would you like to throttle it? Can Kafka do that? Yeah. Yeah, you can play with the offsets. You can say like, get me limited amount of data. Yeah. Yeah. Yes. Yeah, so that's one of the ways you could implement it. But basically, kind of Kafka in the meantime has moved way into the future. So you're reading slowly the data from Kafka. So basically, there is no way to communicate back to Kafka that actually you haven't read that data. And you might be asking Kafka to keep it way longer for you. Maybe, I don't know. Do not delete the data I haven't read. So that's basically a problem with a system that doesn't understand back pressure on the other side. I don't know. You should try it. You should try it. If you want to actually make sure how it works with your version of Kafka, just try it. Let's say plug a slow consumer, plug a very fast Kafka firehose, and see what's happening inside your implementation. I would do that basically, and that's what I usually do with systems. I do not try to second guess the behavior of complex systems. I try to devise tests that are going to be showing me how those systems actually behave. Yeah, I know it's like I think it turned a bit into a kind of Kafka bashing session. I don't think it's kind of it's a real problem. If your consumption is slower than your producer, then actually back pressure is only half of the solution. Because back pressure works best when you have like a difference, temporary difference between uh, the velocities, like production velocities of the producer and the consumer. So then it's going to adapt. But if you have a permanent difference, at least, for instance, if your producer is permanently faster than your consumer, then you need to fix your system. No amount of back pressure is going to help you if, for instance, your data are coming from external telemetry. Imagine you have a rocket. The problem is the rocket. Or the problem are the actual users. If you don't actually start pulling all the data in, then you probably you lose the contact with reality. So this is really bad. So that's for instance the usual answer by the reactive Eric's crowd. For instance, Eric's.js doesn't do back pressure at all. What they say, if the consumer cannot keep up with the producer, zero problem. You should fix it. It's like it's in a permanent way. Yeah, like fluctuation, like maybe 10 minutes, 10 hours, okay, but not permanently. If you permanently cannot keep up, if the this gap is widening, then you probably are looking for a trouble. Well, yeah. So if you're asking like what is the amount of time you can actually allow the disparity between the producer and consumer velocity continue, it depends on how much memory you actually have to store the buffer data. So if you have a lot of memory, then you can consume the data and store it in the memory until those speeds are still are matched again. If you expect them permanently to be unmatched, then yeah, for Kafka, it's basically the size of the log. So you can keep your data in Kafka. So this is another problem. If you do back pressure towards Kafka, and Kafka is not emitting the data, then it keeps the data in the log. So after uh, let's say 7 days or something like that, or any configured time. So if you cannot keep up with that, then you're done, basically. Okay, any more questions? I think we are out of time. Thank you very much. Thanks for the attention.